This is test ID 1 and the subject is communications. The question is number 45. Now this question is about what we call as a time division multiplexing or TDM. Now what we have in this question is we have a set of input signals, band limited input signals, whose bandwidths are given here: 1 kHz, 2 kHz, 4 kHz and 8 kHz. Now in a time division multiplex system, what we have is all these different channels. We call each of these inputs to be different channels, are now passed through a single channel, but the data is passed for different times. Now this is what we call it as a commutator. A commutator switches between the data 1, data 2, data 3 and data 4 in a periodic fashion and then returns back to data 1. Now it's given in the question that each of these data is already sampled at its Nyquist rate. So let Ts be the Nyquist rate for the first one. Now that corresponds to, or the sample rate Rs, which is 1 by Ts, will be twice the message bandwidth, which is 2 kHz. Let's call it Rs1. Now the sample rate for the second one is 1 by, which is actually the bandwidth is twice the first one, so hence it will be 2 by Ts. In this case it is 4 kHz. Similarly for Rs3, it is, since it is 4 times, you will have 4 into 1, that is so it is 4 by Ts, which in this case is 8 kHz, and Rs4 is 8 by Ts, hence it is 16 kHz. So this is the sampling rate for each of these channels. Now a commutator, what it does is it switches from each of these sources and then outputs a data which is running at a much higher rate, compared to Ts, and the data is all multiplexed in time. Say for instance, let's just consider a single time window, that is 0 to Ts. In 0 to Ts seconds, if you look at the first data, only one sample is going to come from that. If you look at the second data, then you would have 2 samples coming from here. And similarly, the fourth one you have 4 samples and the eighth one you have 8 samples coming in. So within a single interval, Ts, you have a total of 1 plus 2 plus 4 plus 8, 15 samples. You have 15 samples coming within Ts seconds. So 15 samples in Ts seconds. And that should be the rate at which your commutator should also actually switch between the channels. So hence 15 samples in Ts seconds, since the bandwidth, that is the rate at which the commutator rate is the sum of all these rates, which is nothing but 2 plus 4 plus 8 plus 16, which is 30 kHz. That is, you would have 30,000 samples per second. That is the rate of the commutator. Now to accommodate this in a channel, this signal is going to be transmitted into a channel. What is the channel bandwidth necessary? That is the question. Now it's very well known that let the bandwidth of the signal be, say, minus W to plus W, then the sample rate is simply 1 over 2W, or the bandwidth necessary would be simply 1 over 2 times Ts. So in our case, it is given that 1 by Ts is nothing but this is Ts refers to, let's call it Ts channel. Tsc is the channel sample rate. Now hence what we would have here is 1 by 2 into 1 by 2 Tsc, which is nothing but we found out here to be 30 kHz by 2, hence it is 15 kHz. So the channel bandwidth necessary to transmit this data would be 15 kilohertz. Hence the correct answer is A.